Okay, in this section, what we're going to be looking at is now how to graph these polynomials. It'll have nothing to do with any of that transformation stuff that we would have talked about in the first chapter. Instead, we're just going to pick out some information from the equations that were given, hopefully the factored equations that were given, and use information that we should kind of already have a feel for to be able to put a pretty nice picture together. We're going to start with this example here of sketching a polynomial. It's a quadratic, so we do know it should be a parabola. It'll be x squared plus 3x minus 10. And what we're going to do is use some properties that hopefully will make a little bit of sense that are listed above. The two big ones are going to come from the inequalities that we've talked about. So if the polynomial is greater than 0, what that means graphically is that that portion of the curve occurs above the x-axis. And so if p of x is less than 0, right, that means y is negative. So that portion of the curve will occur below the below the x-axis, below the horizontal. A couple of other features that we'll use when sketching these. The ends of polynomial curves keep going up or down. So just some examples that we do know about. If we have like a linear curve is a polynomial, if we draw it, right, it would either keep going up on the right or down on the left. There is an exception there. The exception would be unless it's a constant, so I should add that. Which I will. The constant is actually still technically a polynomial, but a constant would just have a flat horizontal graph, and that obviously wouldn't keep going up or down. But any polynomial that actually has some x's in it will just keep going up or down. Parabolas, we know what parabolas look like. On both sides, the curve would just keep going down. If you're familiar with cubics, if you're not, you're gonna be. But they look something like almost like a little weird S curve, and then one side will go up and one side will go down. So they all have that behavior that unless it's completely horizontal, it's going to just go in an upwards trajectory or a downwards trajectory as we go to the outsides, left, right of the picture of the curve. So we can use that for part of our graph because we're going to sort of be wondering, well, what goes on out here, outside here? Well, this tells us what goes on the outsides. And then another useful thing is that polynomial curves are always smooth. They never have any weird corners. So a corner would be something like you'd have, or you might hear it called a cusp. So it would be something that looks like that. Polynomials never have that. They always have this nice smooth pattern where, like, if you rolled your hand along it, it wouldn't catch. There's no jagged pieces. So we won't see anything like this in a polynomial. So let's get to work on sketching this one. What I'm gonna start with is, we'll use the sign properties. So I'm gonna do that first. Call it step 1. I'm gonna get my signs. So my polynomial is p of x equals x squared plus 3x minus 10. To figure out these signs, we want to factor, if you recall. So we're basically solving inequalities to figure out the signs. So this will be x plus 5, x minus 2, the two numbers that multiply to negative 10 and add to 3. And so I know that I get my zeros at x equals negative 5 and x equals 2. And so what I'm going to do is I'm going to put this just in the same sign table that I had done in the, I think, previous chapter. That's a bit bigger than I wanted. Let's do this. So remember, those two numbers are going to be the headers for my column divisions, not the columns. You should be 2. And then I'll list all the factors along the left. And then we just go across and see what the signs look like. Oh, that's a terrible line. So x plus 5 will start negative and then flip over when I cross over -5. X minus 2 is negative, 0 minus 2 is negative, 3 minus 2 is positive. And so this is going to give me my signs, plus, minus, plus. And so we should be able to actually put this together in a graph fairly nicely. So I'm going to just get the graph started. Okay, so I did give tick marks for both the x and the y-axis. We're not really going to say too much about the y-axis for the polynomial graphs. We're more interested just in if it's above or below, like if it's in the positives or negatives. So don't worry too much about scale, because aside from y equals 0, we don't really care that much. Yeah, so I've got my signs. I'm going to sketch now. So you might want to break this into sub-steps. So maybe I'll start by sketching the zeros first. So those are at x equals -5 and x equals 2. So that's going to give us points at -5 and 0 and 2 and 0. And then what I could do is draw a positive region. Maybe I'll do that for blue. So p of x is greater than 0. So that's where we have these pluses. So the positive region is going to go from -5 onwards to 2 onwards. So should look like that. And remember, as we do that, it's not going to do anything weird like flatten out because of the ends going upward, sort of like infinite behavior. So we don't get any weird flattening out. Just make it as simple as possible. So you're going to go from that point. It is entirely connected. I guess I probably should have added that as well in my list. But it'll go up something like that. I am going to, in fact, add that up here. Nope, I'll just use the lighter font. Or continuous, if you are familiar with that term. So because of that, that does mean that my curve has to go right to those points. It can't just sort of float away from that point. And then for the last step, I will do the p of x being less than 0. So that's where everything is negative. So that's going to be between these 2 points, the -5 and 2. And I basically am just connecting. So something like that. And so that entire curve, I'm going to go over it now in black, because that's our actual curve here. I don't know if I've got my vertex in the right place, but for the style of graphing I've asked, it's not that important. And so that would be basically our graph. It's not the most perfect shape, but hopefully you can recognize that that is, in fact, a parabola. I think the vertex would be at like -1.5. You can plug it in and see what y actually should be down here, but I don't think I have it in the right place, but I wasn't looking for it. All I really care about is that the blue part that I drew is in the right place-ish. It's above when it's supposed to be above. The green is below when it's supposed to be below. So this is a different way of graphing something like this. Now, if I handed you a parabola, you would probably just use parabola graphing techniques. Me personally, I actually like to graph the zeros and then just kind of connect the dots from there. But we don't have special techniques for graphing, for example, cubics or anything higher than that. So that's where using these signs are going to come in handy a little bit more. Okay, so for a second example, let's change that number. So for this one, I'm not actually giving you the polynomial equation, but I'll tell you that it's got zeros at -3, 2, and 4, and the following signs. So it's as if I gave you the polynomial and you had already figured out the table. So we have to do a little bit less work for this one. But yeah, so we should be able to use all the properties listed above to get an idea of what this picture is going to look like. We can start with the same thing from before. I'll start by plotting those zeros at -3, 2, and 4. And I'm just going to tell myself where it's positive and where it's negative. So positive on the negative infinity to -3, and then 2 to 4, and then 4 onwards. So it should be positive there, which means above the x-axis, and then negative for this -3 to 2 region. And so what I can do is now just sort of draw my curve that's going to do all those things. So on the leftmost side, it's positive, so I've got to make it do something like that in the positives, and then it's below, so it's going to come down like this, and then it's entirely in the positives. So I'm going to go through and make a couple of really common mistakes here. The first would be to do something like this. So the big mistake with what I've got on the right is that this is going to fail the vertical line test if I were to do this. Right? If I do this vertical line test, that's not a function. So this is bad. So I need to fix that. So let's say we try and fix it by maybe just putting an open dot there so that it is a function. Okay, so now it's a function, but now it's not connected, because I've got this floaty point down here that's not connected with the rest of that curve. And also that curve's not connected because there's a little hole in it. So this is a problem. I need to deal with that. So I'm gonna, yeah, I have to make my curve actually come to that second lower point there. So the next thing I'm going to have to do, and this is what I'll typically see, this is the most common mistake, and it's a fairly natural one to make, because usually you realize you have to connect the dots, you have to hit the zeros. Most people are good with that. So we have to hit the 0, and so you do it in this nice smooth way, and then we hit that 0, and then normally you want to go through and keep going, but that's a problem because it's supposed to be positive on the right, and so then you'll be like, oh, I have to fix that. So I'll backtrack, and then like, bam, now it's positive on the right. So this is a 4.5 out of 5. It's almost there for that rightmost segment, but now the big problem is that it's not smooth. What we've got is this juddy little corner when it hits that point. So you have to be really careful when the curve doesn't change signs across a 0, because your tendency is going to be to want to make it just like it was a car, like just driving into that wall, because every other time the car gets to drive through the wall, but now this one, there's actually a wall there that's going to stop you, and so you have to turn around. So what you've got to do is ease into it. So we're going to have to backtrack a little bit more and ease into how we draw that like this. So you see how I kind of realize I'm going to have to flip back up beforehand. So to prevent my curve from having to hit that wall sharply, I've got to ease into it. Or if like you're driving and you want to avoid hitting that wall, you're going to start turning before you get to the wall. And then turn around and go back up and stay in the positives. So this would actually be a pretty good idea of what this curve would look like here. So yeah, that would be it. All right, so we'll just do one more, not entirely from scratch, we'll do it from factored. All right, so the last one that we'll do for the polynomials for this style of graphing is going to be this p of x equals, and it's a doozy. If you want to actually count the degree of this polynomial, it would be 2. This will contribute 3 x's, 4 x's, and then 1 x. So would that be 10? yeah, that should be a 10th degree polynomial, but we're going to be able to graph this actually pretty quickly. Get rid of that red marks. You don't have to expand and simplify. Don't do that. That would be, that's going to take more time than to actually graph the thing. So factored is nice. And yeah, step one, we're going to get our zeros and signs. So I'll write that out in red. Since it's factored, the zeros should be pretty quick. And then the signs is just going to be doing that table. All right, so our zeros. Don't forget the x is there. That gives us an x equals 0. And then we look at the brackets, the -2, the 1, and the 4. So those aren't quite in order, but they're pretty close. So I'll set up my table. So I'll start with, let's say, -2, 0, yeah, 1, 4. That'll be in my increasing order. And set up the columns so the lines go right underneath all of those numbers. And then list all of my factors. Again, this was emphasized before, but it's going to be really important to list all your factors with their multiplicity. So it's not just the factor of x, it's the x squared, the x plus 2 cubed. So I'm just doing them in a different color to try to call your attention to them. X minus 1 to the 4. And x minus 4. And some of them will be really quick, which is nice. We've got like x squared. Because that's a positive, I do know that that's going to be, sorry, because it's square, it's going to be positive everywhere. And then the same with the 4. Any even powers are basically just squares of something. And so we do know that those are going to be positive everywhere. And the cube, I'll do the x minus 4 first, I guess. It's a little easier. So I know that like this is a line that starts in the negatives and becomes positive when it goes through its 0 of 4, the number that I plug in to get 0. A cube, so we can treat a cube just like a linear piece or any other odd power, because a negative cubed is negative and a positive cubed is positive. So I know if I plug in like -3, I'll get -1, and the cube is going to keep it negative. Now, if I plug in -1, I will get +1, and the cube will keep it positive. And then everything after that will just be bigger and bigger. So this is going to be my sign setup. 2 negatives make a positive. 1 negative makes a negative. Yeah, 1 negative. Oh, I got a bunch there. And then 4 positives make a positive. All right. So we should be able to graph this now. All right, so I've got my table set up. I don't really care about the y-axis. I'm going to do my graph now. And I'll just follow the same order as before. Always start with those features that you know. So we'll start with our zeros at 0, -2, 1, and 4. And so I've got my zeros, and then I'm going to label my signs the same as I've been doing. So the plus, like you don't have to draw these, but I'm doing it so that you can really see where everything's coming from. So my positives, 4 onwards, and then my negatives are the 3 regions in between. Okay, and so we'll get something like, yeah, something like this. So something I want you to be mindful of when we're going through this, before I put the graph together, so I was saying before to label these numbers or the powers of the exponents. Those are called the multiplicity specifically, and the multiplicity of the 0. So what we're going to see here, I'm going to label above each number here the multiplicity of its 0. So the -2 comes from the x plus 2 cubed. So I'm just going to put in brackets that 3 for the power that goes with its factor. The 0 comes from x squared. The 1 comes from x plus 1 to the 4. And the 4 comes from x minus 4 to the 1. So if you notice a pattern here, the two odd ones are 3 and 1. So let's maybe circle those in orange for odd. And so notice what's happening at the bottom at the odd powers. And let's find a color I haven't used before, maybe the purple, for the two even powers. And if you look at what's happening with the powers at the bottom, and we're going to use this later, but basically the odd powers cause the sign to change. And that's because at the 0, the powers change. And at the 1, those powers change. So that sign changing that happens because of the odd power is going to carry through to the whole sign of the function. Meanwhile, at the even powers, their corresponding 0 does not change. So the 0, for example, this one doesn't change, and none of the other ones are going to change because they're nowhere close to 0. And the 4, you'll see, the 1, those signs don't change. None of the signs change there. And so that's why we get the exact same power. It doesn't, the exact same sign. The signs don't change at the even multiplicities, and the signs do change at the odd multiplicities. So we're going to use that fact later in a different style of graphing these that you might find more efficient. But I like this style because you end up doing something really similar in calculus. So I like to teach it this way. Yeah, so we should be just putting this together. We are going to want to be mindful of, if you remember with the last example, down on the bottom, we don't have any of those sign changes. So we have to be really careful about making sure those are smooth and not just do like sharp little points to connect those. So they look pretty smooth there, and then it's going to go in the plus and the plus. So that's more or less what your graph is going to look like. We could go a little further and say that because at the -2, there's a higher multiplicity. Let's see, yeah. So at -2, it's going to look like we've got our 0. We had that multiplicity, it was 3. So technically what actually should happen there is instead of it going through kind of like that, as we have in the picture, it actually will level out and then go through like a bit like that. But we don't really have the tools to justify the fact that it's doing that. So I don't care if you don't do that. So that's why I'm perfectly happy to just leave the graph the way it is on the right. Those are the features we're looking for in this class. Again, if you're taking calculus, you'll do a lot more graphing. You'll see why it actually is going to level out at that -2, but we have no concept of that right now, so don't worry about it. So this would be our graph on the right. This would be a polynomial. So, all right, and so in the other lessons, what I'm going to do is just basically give you another method that you can use to graph these, which is more consistent with what you'll see in textbooks.